Hello students. So far we have seen objective questions and questions of 2 and 3 marks in optics. Today I am going to tell you about the questions of 5 marks in optics. First we will see some questions from ray optics and then from wave optics. This time I will give you hints only so that you can prepare answers by yourself. In ray optics, you may recall there is an important relation known as lens maker's relation or formula. The first question is about that. So the question is, for refraction through a thin lens, derive the relation 1 by f is equal to mu 2 by mu 1 minus 1 times 1 by r1 minus 1 by r2, where terms have usual meanings. The answer of this question is not difficult. There is a very simple derivation that you can follow from the lesson of refraction at spherical surfaces. In that we find two relations. One is mu 1 by minus u plus mu 2 by v is equal to mu 2 minus mu 1 times 1 by r, which is obtained when refraction takes place while light ray moves from rarer to denser medium. And second relation is mu 2 by minus u plus mu 1 by v is equal to mu 1 minus mu 2 times 1 by r, which is obtained when refraction takes place when ray moves from denser to rarer medium. For deriving lens maker's formula, these two relations are used, since light ray refracting through a lens first moves from air to the material of the lens, being refracted at first surface of the lens, and then again moves to air, being refracted at second surface of the lens. So the derivation is done in two steps, and accordingly two relations are used. The image formed in first step, that is by first surface, serves as object for the second surface. Let us now move to the second question. Question number 2. What is the angle of minimum deviation? For refraction of light through a prism, establish the relation mu is equal to sine A plus delta m by 2 divided by sine A by 2, where terms have usual meanings. To derive the relation for refractive index of material of a prism, you have to use the ray diagram of refraction of light ray through the prism. By using geometry, the derivation is done. You can find the derivation in the lesson Refraction and Dispersion through Prism. The third question is about optical instrument. The question is, draw a labeled diagram to show the formation of image of an object in a compound microscope. Derive an expression for its magnifying power. For this, you have to draw a ray diagram for the image formation in compound microscope, and you must show the objective, eyepiece, distances of object, image, focal lengths of the lenses, etc. properly. For magnification, as you know, it is the ratio of image height h dash to the object height h. So for its derivation, you have to use geometry referring the diagram. You can follow the derivation from the lesson Optical Instruments. In the similar manner, instead of compound microscope, a question may come for an astronomical telescope. My suggestion is that you practice the derivations of mirror formula and lens formula also. Next question is from wave optics. Question number 4. Define wavefront and secondary wavelets. Establish the laws of refraction of light on the basis of Huygens principle. Here, first you have to give definitions of wavefront and secondary wavelets. And for establishing the laws of refraction using wave theory, you can follow the lesson refraction at spherical surfaces. Same question may come for establishing laws of reflection using wave theory also. Now, question number 5. Distinguish between interference and diffraction of light. Explain the diffraction of light by a single slit. In the first part, you have to mention the differences between the two phenomena. And for the second part, you have to explain the process of diffraction, drawing a diagram and then giving the conditions for minima and maxima of diffraction pattern. Next question is from interference. So, question number 6. Describe Young's double slit experiment with necessary theory and obtain expression for fringe width. For describing Young's double slit experiment, you have to draw a diagram of the experimental setup, that is, experimental arrangement, showing superposition of two secondary waves originating from the two slits and formation of bright and dark fringes on the screen. For the second part, that is for fringe width, draw another diagram showing path difference between two superimposing waves from the slits, forming a fringe on screen at some distance from the central point. You can follow the derivation explained in the lesson Interference, covering Young's double slit experiment and fringe width of interference pattern. Question number 7 covers polarization of light, and the question is, what is meant by polarization of light? With the help of a diagram, show polarization by reflection when light ray falls at polarizing angle. Derive the relation between refractive index mu and polarizing angle IP and name the law by which this relation is known. I have already explained the phenomenon of polarization in short answer type questions. You go through that and also see the lesson of polarization in which you will find the derivation. I hope you remember the name of the law, so I am leaving that for you. With this, I am ending the session today. I hope my suggestions will help you in preparing the answers. You go through the lessons and practice all the derivations of important relations. Good luck.